Okay, hello, my little friends. Another day, another lesson. EF-6, here we are, percent increase and percent decrease. But before we talk about our actual lesson, we have to talk about percent with decimals and decimal form. So we have to be able to go back and forth pretty easily in our lessons for today and tomorrow. So what does that mean? Okay, well, if I want to turn a percent into a decimal, what do I do? Okay, so remember way back when all of our percents are taken out of 100. So you start with 100% and it either goes down or it goes up, okay? So if I wanted to do that, I would be 23 out of 100, and I could put this into my calculator and get 23 divided by 100, and that's going to give me 0.23. Okay. Otherwise, there's a trick too, right? So I would have 0.23. So what do I actually do here? Well, it's the queen bee herself who always said, to the left, put everything you own in the box to the left. You know, good old Beyonce. And that is what we do here. So if I want to change something from a percent into a decimal, okay, what are you going to do? Well, you are going to, right where you see the end of the number, so I see 2, 3, okay? At the end of the 3, I'm going to pretend like there's a decimal there, okay? So it would be 23.0, okay? Because that's technically what it's saying. It's 23.0. And then I'm going to move that decimal, to the left, and then that is your decimal form. So it would leave you with 0.23. Okay, well, what about here? I have something on the other side of that decimal, that 0.4. I don't care. I'm moving the decimal only to the left, 2 times. So 1, 2. Now the decimal belongs here, and I'm at 0.584. Okay, same idea here. So I'm going to move this decimal 1, 2. Okay, but there's an empty spot here, so you just include a little 0 there. So this is going to be 0.049. Oh, what about here? No difference. We are still moving to the left twice. So 1, 2, put a decimal, empty holes, you put a 0. So I'm going to have 0.002. Okay. This one, I don't see a decimal, I don't see a decimal, I don't see a decimal, and I don't see any more numbers. That means the decimal goes right here. So we're looking at 256.0, and I go to the left, to the left. So I go to the left, and the decimal goes right here. So I'm left with 2.56 as my percent, okay? So to change percent to decimal, move 2 times to the left. Okay, now what about doing a decimal to a percent? Okay, well, if I went 2 times to the left, that means that this one, I should go 2 times to the right. Okay, so this one, I went to the left. This one, I'm going to the right. So I'm going 2 to the right. So 1, 2, that means I'm at 27%. Okay, I'm going 1, 2, that means I'm at 79.4%. Okay, here's my decimal. I go 1, 2, that means I am only at 3% because I don't need to write those zeros. And I go 1, 2, that means I'm at 231%. Whoa! Okay, so that's going to come up a lot when we talk about percent growth and decay. Here is a new equation for us, and an easy way to remember this equation is all people won the race together, okay? All people won. Actually, let's use our math words. Won the race together. AP1RT, okay? AP1RT. What does this mean? A is your amount, okay? The amount. P is called principal amount. This is what you start with, Okay, so what somebody started it with money in their bank account and then they added money, or how much a car was worth at the beginning and then it gets smaller, that kind of stuff. 1 plus or minus does not change, always the same. This is the rate that it changes. This is where these things are going to come in, because it's going to give us a percent normally, and then we have to change the percent to a decimal, and this is time. Okay, so I guess I'll just write amount here. The amount equals the principal times 1 plus or minus the rate to the time. Now, this plus or minus is going to come from if something is increasing or decreasing, and they love to use fancy words with these. So words that increase mean increased, you'll see increased by. Okay, you're going to see something like earned. So it earned interest. You'll see, say, the account grew or grows at a certain percent. Anything that indicates that it's getting bigger. Words that indicate decrease. Okay, well, decrease by. The one they really like to say is depreciated. They like to use this one with cars. Okay, so the car depreciated by 15% each year. Decays. So sample decays at a certain rate. Okay. Now, this y equals a times b to the x is primarily the same equation, only this b, when we use this, it usually gives you things like double or triple or quadruple. When we use this, they're giving us percents. They're giving us rates, not just normal numbers, okay? But we're going to talk about what's happening here. Is this a percent increase or is it a percent decrease? So what we're doing is the number bigger or smaller than 1. Okay, so is this number in parentheses bigger or smaller than 1? So if I look at this, 1 is being increased by 0.25. So that means that this is an increase because it's larger than 1. Inside this right here, I get 0.5. Well, 0.5 is smaller than 1. Okay, so this is a decrease. Alrighty, and then this last one, 1 is getting smaller because it's a subtraction by 0.2. So since I'm subtracting something, this is also a decrease. Okay, not too bad so far. We got this, right? All right, so let's get into the nitty-gritty. Okay, so here's the difference. Notice what it's saying to you. A savings account grows. So grows means it's getting bigger. So this is a plus, okay, by 3% per year. Sophia places $500 in the account at the beginning of the year. So notice the big idea here. This right here, you see this percent? If you see a percent, you are looking at this equation. All people won the race together. Okay, because this R is the rate, this 3%, okay? So how much does Sophia have at the end of the year once her 500 has been increased by 3%? Okay, how much? So the amount. How much does she have? Well, the amount in her account. P is the principal, or what she starts with. So she started with 500. Parenthesis 1 is part of the equation. Do not get rid of that. Now I have to decide if I'm adding or subtracting. So that big word. So this one says grows. So that means I'm adding. Okay. This 3% must be a decimal. Okay. So I turn the decimal, this percent, into a decimal. So remember, Remember Beyonce's words, to the left, and a 0 goes in any empty place. So I'm going to be adding 0.03. And the T is the time. So how much at the end of the year? So it's 1 year. Okay. In my calculator, I am just going to do exactly this. So I'm going to put 500 parenthesis. I know you can't see it because it's terrible under the Elmo, but 1 plus 0.03 caret 1. Okay, so her amount is $515. Okay. How much does Sophia have at the end of the second year? All right. After it's been increased by 3%. So nothing changes. Her amount, she starts with 500. Parenthesis 1 is part of the equation. Her bank account is growing, so I'm adding. 0.03 is that percent in decimal form. And now the second year, so T is now 2 because it's year 2. Okay, so now I'm just going to do the same thing. 500, parenthesis 1 plus 0.03 raised to the second power. Okay, so I'm going to get 500, sorry, I think I screwed that up. 1 plus, oopsies, there, yes, I did screw it up. 0.03 squared. Okay, so I'm going to get her amount is $530.45. Okay. Did the amount of money in Sophia's account grow faster in the first year or in the second year? Explain how you arrived. Okay, well, from year 1, or from year 0 to year 1, she had 500 and she ended up with 515. So we're going to say 515 minus 500. So that means in her first year, she made $15. Okay. What about year 1 to year 2? Okay. Well, in year 2, she had $530.45 at the beginning of the year. And she started with 515. Okay, so I'm going to do that subtraction, which is $15.45. Okay, so this is larger than this. Okay, so the second year, because 15, oopsies, that's putting things in the wrong order. $15.45 is bigger than $15. Okay. This is an uncommon question. You're not going to see that too much. Okay. These are our last examples. Next one. An environmental firm is removing pollution from a river. They find the pollution is decreasing at a rate of 5% per month and measured in parts per million. The pollution starts off at a level of 360 parts per million. What is the pollution level 1 month after they begin cleanup? All right, first thing you see this 5%? That means you are dealing with all people won the race together. That percent indicates this equation. The amount, what does that equal? P, how much did it start with? Okay, it says it started with 360 parts per million. Parenthesis 1, part of the equation. Okay, now I have to now decide if I'm adding or subtracting. It says, pollution is decreasing. So decreasing means I'm subtracting. Subtracting what? The rate. What is the rate? Well, the rate comes from this right here. I have to turn this 5% into a decimal before I can stick it into this equation. And how do I do that? Well, I put it at the end and I move to the left twice. I fill in any holes with zeros, so I'm going to get 0.05. And T. T is the amount of time it's asking me in the question. So this would be a 1 because it's 1 month. All right, 360 in parenthesis 1 minus 0.05 all raised to the 1. So the amount of bacteria is oopsies. My amount of bacteria went up because I put 390, not 360, is 342 parts per million. Okay. Alrighty. What is the level 2 months after the after whatever started happening? All I'm doing is changing the time. She starts with 360, parenthesis 1, part of the equation. I'm decreasing in parts per million by 5%, and I'm after 2 months now. So 2 months, the 2 is going to go right there. So 361 minus 0.05 squared. So the amount after 2 months is 324.9 parts per million. Awesome. Yeah. Okay. So for A, B, and C, determine the initial amount and state the rate of increase or decrease. This is what gets everybody. Okay. This right here. Inside the parentheses, is this bigger or smaller than 1? Okay. This is bigger than 1. How much bigger than 1? 0.25 bigger than 1. So I'm 0.25 larger than 1. I am going, because notice it says state the rate. The rate is the parenthesis, or the percent, okay? So I want to go to the right to turn this into a percent. So this is a 25% increase. Okay, increase because it's bigger than 1. How much bigger than 1? 0.25, and 0.25 in a percent is 25%. Now, what is the initial amount? Well, this is the initial amount. It's the number in front of the parentheses. Let's look at this one. Initial amount first, because that's easiest. What's the initial amount? It's the number in front of the parentheses. It's 20. Okay. Alrighty. These ones are a little tricky because what are you asking yourself? Remember, I am bigger or smaller than 1. Okay. I'm smaller than 1. Which indicates a decrease. But how much smaller than 1 am I? How much would I have to get to 0.6 if I gave you 60 cents? How much more would I have to give you to have $1? Basically is what this is. So this would be 1 minus what equals 0.60. Okay, so how much do you have to add to get to 1? That's how much was taken away. So here I have a decrease of 40%. Because I would have 0.4 to get to 100, and there you are. Okay, initial amount is, the number in front of the parentheses is 20. Alrighty, here we are. 0.95, bigger or smaller than 1? Smaller. Decrease. Decrease of what? Well, 1 minus what gives you 0.95. Okay, if I had $1 and then I was left with 95 cents, how much did you take away from me? Well, you took away a nickel. You took away 5 cents because 1 minus 5 cents is 95. To turn this into a percent, I move it to the right. So here I would get a 5% decrease. Okay, all of these in here is basically saying how far away from 1 are you? I am 0.05 far away from 1. I am 0.40 far away from 1. I am 2, 5 away from 1. Okay. Alrighty. This was a Regents question, and it got a lot of students. Okay. Last question. A high school sponsored a badminton tournament. After each round, 1/2 of the players were eliminated. If there were 64 players at the start of the tournament, which equation models the number of players after 3 rounds? Okay, so 3 rounds is my time. That's how much time they're going to be playing. 64 players is what I started with. So that's who starts in this round robin. So let's eliminate some things here. So 64 players is what I start with. So if I had this equation, P is what I start with, right? So P is the amount of people here, and it should be 64. 64. Okay, so nothing good there. 1 plus or minus the rate to the time. Well, I know the time, that sticks out at me. The time is 3 rounds. Okay, 3 rounds. So this one says 0.5 rounds and this one says 0.5 rounds. So it can't be those two. Now let's look at these. After each round, 1/2 of the players were eliminated. So do you think I should be adding or subtracting my rate here? Eliminated? You better believe I better be subtracting. So it has to be 1. Why is the rate 0.5? Because 1/2 gets eliminated. Alrighty. So I hope you have the world's best day ever, and I will hopefully see you guys soon.